right, in these notes, we're going to introduce what are called the trigonometric ratios, or trig ratios for short. There are three types of trig ratios. The first one is sine, and sine is abbreviated with the three letters SIN. Now, we know it's tempting to call that sin, because that's how you spell it, but in order for us to sound like smart geometry students, we're going to say that anytime that we see the abbreviation SIN, it's sine, okay? The second one is called cosine, and again, the abbreviation for this one is going to be COS, so it's not cos, it's cosine. And the last one is going to be tangent, and tangent is abbreviated with TAN. So not tan whenever you see those three letters, but you have to say the whole word tangent. And we are going to be strict with that when we ask you for questions or responses that you are saying, in fact, the entire trig ratio. Again, this is just going to make your life easier in the future as you take the trigonometry class or you go on to calculus or whatever it is, okay? Now, these three trig ratios are based on a right triangle, and right now for us, all the triangles that we're going to be working with are going to be right triangles. And so remember, a right triangle has a 90-degree angle, and it's shown with this box here. The side across from the right angle is always going to be called the hypotenuse. No matter which way you draw the triangle, the side across from it will always be the hypotenuse. And the hypotenuse is going to be the only side that doesn't change when we're describing it. But we're going to be describing these words based on which angle we're standing in. So in this case, if I tell you that we're going to be based off of angle A, I like to draw a little sig figure here. And if I look opposite to me, this is going to be the opposite side of A, okay? This is going to be the adjacent side of A, and adjacent, remember, means next to. So depending on which angle we are talking about, we're going to label our sides as opposite and adjacent. Same thing over here in the second picture. The second picture, if I tell you that we're going to be working with angle B, I would draw in my stick figure again. Now, this would be the opposite side of B, and this would be the adjacent. That one would be next to now. So again, in the triangle, the only thing that doesn't change is the hypotenuse, but then depending on which angle we're talking about, the opposite and the adjacent are going to change for our picture. Okay, so this is what's called an acronym, and this acronym is going to help us set up our trig ratios. The acronym is SOHCAHTOA, and you will hear people talking about SOHCAHTOA. This is what they're talking about. So let's talk about where these letters for the acronym come in, the SOHCAHTOA. The S for the first part comes from sine, and here's where the other letters come in, O and H. Sorry, that's the name. O and H. O stands for opposite. H stands for hypotenuse. Okay, and this line is a fraction. So the opposite is in the numerator, the hypotenuse is in the denominator for SOH. So SOH, that's where the first part of this acronym, SO, comes from. Then I have cosine, so that's the C. And then the other parts of the acronym, there are A and H. So CA. A stands for adjacent, that means next to. And the H, again, stands for hypotenuse. Okay, and again, this is a fraction, so you're putting the adjacent side over the hypotenuse. And so these letters, C, A, H, that's how I come up with the CA term. Okay, and lastly, we have tangent. So T, O, A, TOA. O, again, anytime you see O, that means opposite. And anytime you see A, that means adjacent. So TOA is TOA. And SOHCAHTOA is going to help us remember these proportions. So we're essentially creating a fraction, comparing these sides. And so we use the opposite and the hypotenuse for sine, adjacent hypotenuse for cosine, and opposite and adjacent for tangent. Okay? So when we're doing these problems, you might want to write the acronym SOHCAHTOA next to your paper or next to the problem. That way you can go back and reference it. So when we do here, I'm going to start by doing example 1. I'm going to write down my acronym, and it's important that you write down the right letters. Otherwise, it's not really going to help you, okay? So, and then we are going to start off with angle R, and angle R is here. So I'm going to mark my angle, and I want to make sure that my stick figure is like going to walk along this side, okay? And then I'm going to start labeling this picture. So if I'm standing here at angle R, this 5 would be my adjacent. I can walk along my adjacent side, which means that if I look across, this 12 becomes my opposite. Now there's one that will never change no matter which angle I'm standing at, and that's going to be the hypotenuse. Okay, for me, 13 will always be the hypotenuse because that's across the 90-degree angle. That is always, always, always going to be the case. So when we're setting up our trig ratios here, I'm going to write down I'm going to start off with the first letters. And remember, those stand for the trig ratio. So I'm going to say sine, and we're always going to reference the angle that we're standing at or talking about, cosine of the exact same angle, and tangent of that same angle. If I had an actual angle measurement, like if it told you that the angle was 40 degrees or whatever, you would actually put it in there instead of the R. But right now we don't know what the angle is, okay? So then I'm going to go along and I'm going to go O and H. Now remember, these are creating a fraction where the O is in the numerator and the H is in the denominator. And now that I labeled my picture, that's going to make it a little bit easier. So my opposite in this case is 12, and my hypotenuse in this picture is 13. Okay, going along, A and then H, so that's A in the numerator, H in the denominator, that's what that means. The adjacent in this case is 5, and the hypotenuse in this case is 13. Okay, and the last one here, tangent is O and A. So opposite in the numerator, adjacent in the denominator. Opposite is 12, adjacent is 5, and that would be my answer. Now on your final answer, you don't really need these letters on the right side, but if it helps you, feel free to write those down. Okay, so that's it. If we're asking you to find or set up the 3 trig ratios, this is it. Sine, cosine, tangent, and you are creating those fractions that represent the ratio. So I'm going to go ahead and do angle S, but I'm going to clear my picture here. Everything is going to change except the hypotenuse. Remember, we talked about the hypotenuse will always stay the same. Okay, so I'm going to go ahead and do sine of S now, because we are always going with the angle they're telling me. Cosine of S, tangent of S. So if I'm standing here at this angle, now I'm standing at S, this across from me is going to be the opposite, and then this next to me is going to be the adjacent. I can walk along the adjacent. So this is changing my ratios because I'm at a different angle now. So again, starting with S, I know that S is so. Opposite is 5 this time. The hypotenuse stayed the same. It's still 13. Then I have ka. So the adjacent is 12, and the hypotenuse stays the same. And then tangent is toa. So the opposite here, now I'm looking here, is 5, and my adjacent is 12. Okay, so you have created the 3 trig ratios now based on angle S. So again, I don't need those letters, but I'll leave them there in case they help you. So these fractions are going to change based on whichever angle that we are talking about. Okay. So let's go ahead and try number 2. Go ahead and pause this video. Start off by writing SOHCAHTOA off to the side and see if you can figure out the 3 trig ratios for each of the angles. Okay, so hopefully you did try these on your own. So we are talking about sine of angle A, cosine of angle A, and tangent of angle A. Okay, so if I'm standing here at angle A, I'm going to label this. Well, for sure, always, this is the hypotenuse across the 90-degree angle. I'm just going to use the first letter for these. If I'm standing here, this is opposite to me, and this is adjacent to me. Okay? So let's go ahead and start creating my fractions. So it's O and H. So O I labeled as 12. H for hypotenuse is 20. And that's my fraction for sine. The next one is ka. So I know that's A in the numerator, H in the denominator. In this case, my A is 16. And my hypotenuse is 20 still. And lastly, I have tangent, which is TOA. Opposite, in this case, is 12. And adjacent is 16. Okay, and I'm done with the trig ratios for angle A. Now going on to angle B is here. And if I am standing at angle B, this is going to change 2 of my letters. This is now opposite to me, and this is now adjacent to me. Those are the only ones that change. Hypotenuse stays the same for both. Okay? So I'm going to go ahead and write my 3 trig ratios. Sine of angle B, cosine of angle B, and tangent of angle B. All right, so now that I went ahead and changed my letters, my new O is 16, and my hypotenuse is the same, so that was opposite over hypotenuse. Cosine is adjacent over hypotenuse. Now I changed that to be 12 is my new adjacent, and my hypotenuse is the same. And the last one, TOA, my opposite is now 16, and my adjacent is 12. Okay, and these would be the 3 trig ratios for angle B. So we ask you to write down the 3 trig ratios for a specific angle. That's all you need to do is set up that fraction, okay? We are going to use these later to solve for a variable, but right now we just want you to be comfortable with being able to identify the opposite, the adjacent, and the hypotenuse, and being able to set up those fractions. Now, so what are these trig ratios? We're going to be working with the actual values of what these 3 trig ratios do for degrees. So what we're going to do right now is we're going to enter this in the calculator. Now, in our calculators, whether you're using the scientific or the graphing calculator, we need to make sure that we are in degrees mode. Okay. There's 2 modes in the calculator right now, is degrees and radians. So we want to make sure that we're talking about degrees because we're going to be measuring angles, and angles are measured in degrees. And then what we're going to do is identify, you should see in your calculator, buttons that say sine, cosine, and tangent. So you just click the button, enter the number, and I want you to make sure that you are practicing this on your own. When you type in sine and then enter the number 48, close the parentheses, you should get 0.7431. So this is just getting you used to using those numbers. Okay, we're going to be using these values later on once we start solving. If I type the cosine button and then 13, I should get 0.9744. And then same thing with tangent. If I type in tangent of 81 degrees, I should get 6.3138. Okay, so again, Right now, we're just practicing entering in those numbers into the calculator and seeing what value we get. This will come in handy here in a little bit. Okay, and 6 and 7, this is where we're going to do these trig ratios and then stop. Because again, we want to make sure that you guys are comfortable finding the opposite, adjacent, and hypotenuse. And then in a different video, we're going to actually solve for the values of these variables. So right now, we are only going to set up the 3 trig ratios for the given angles only, okay? So let's go ahead and do that. For number 6, again, we're using the given angle. So this is the angle that's given. And when we're talking about setting up the 3 trig ratios, we never use the 90-degree angle, okay? We're always going to use the two, one or the other of the acute angles, so not the 90-degree angle. If I'm standing here, okay, this is going to be my opposite side, this is going to be my adjacent side, and this is going to be my hypotenuse side. It is important that you are careful between adjacent and hypotenuse. Remember that hypotenuse is always across your 90-degree angle, no matter what. So we are only going to do the very first part, which is asking me to set up the 3 trig ratios for the given angle. In this case, I have an angle of 36. So earlier, we said angle of the letter or sine of the lettered angle, but this time we have an angle measurement. So I'm going to include the angle measurement there. And as a reminder, we are using SOHCAHTOA to set up our ratio here. Okay, so we have SO, which is opposite over hypotenuse. In this case, my opposite is represented by the letter S, and my hypotenuse is represented by the letter R. Going on, I have cosine of, again, the same angle, 36. And cosine is adjacent. In this case, my adjacent is 4. And my hypotenuse, again, is the letter R. And lastly, I have tangent. And tangent of my angle 36 is equal to opposite. So in this case, that's S over my adjacent in this case is 4. All right, and that is all we're going to do right now. Just setting up these trig ratios. Again, in a different video, we're going to see how we use these trig ratios to solve for the missing sides. Okay. Now, the next example, we're going to do the same thing, just with a different angle this time. So here I have the angle 22. In this triangle, this would be opposite to me, this would be adjacent to me, and this is my hypotenuse. So I'm going to set up using SOHCAHTOA. I am using sine of my given angle, 22. I'll set that up here in a second. Cosine of my angle, and tangent of my angle. And use that acronym to help me build my fractions. Sine is opposite, which is 6, over hypotenuse, which is x. Cosine is adjacent, which is y, and hypotenuse, which is x. And tangent is opposite, which is 6, over adjacent, which is y. Okay, so right now, again, we're just practicing setting up these ratios. In a different video, we're going to come back and actually use these to find the value of each variable. So for now, this is the end of this video.